A very warm welcome, everyone. My name is Akansha Pandey. Currently, I'm working as assistant professor in IIMT College of Pharmacy. Today, I'm here to deliver my lecture on the topic unit operation. Before moving forward, I would like to share the content I'm going to deliver in this lecture. Firstly, I'm going to introduce what the term exactly the unit operation is. And second, I'm going to give a brief introduction about the stages going to involve during the whole unit operation procedure. See, next two are which I'm going to deliver in this lecture are the size reduction and size separation, which are the basic stages going to be involved during the unit operation procedures. And in size reduction, I'm going to give a brief introduction about hammer mill and ball mill. And in size separation, I'm going to just give a brief introduction about the size, sieves, and cyclone separator. Okay. Moving forward, the first question is, what is unit operation? Exactly, if we are talking about unit operation, everyone has the question in their mind, what is exactly the unit operation is. In pharmaceutical engineering, a unit operation is a basic step in a process which involves a physical change of chemical transformation such as separation, crystallization, evaporation, filtration, polymerization, isomerization, and other reactions. Okay, exactly if we talk about the unit operation, basically it is a process that involves the physical change as well as chemical transformation. If we talk about basically these are the 6 steps going to involve during the unit operation procedure. The very first is size reduction. If we are taking just as it is as example, the very first step of any formulation, any formulation steps, the very first is size reduction. If we have the any compound in bulky manner, what we need to do, we need to just reduce its size to the desired particle size which we want. Okay, so these are the physical change. If we talk about the chemical transformation, we need to mix up that ingredient so that the ingredient with them enhances their therapeutic effect. So basically the physical change of chemical transformation involved during the process, involved in any process, is known as unit operation. Okay. Moving forward, what is size reduction? The process in which the particle size of a substance is reduced from its smaller size to final stage of subdivision is known as size reduction. See, already I have told you, if we want to formulate any formulation, the very first step is size reduction, because as we have the bulky amount of compound, we need to just reduce their size. So it is a very first step, and the size reduction is known as the making any compound to its finer state, or the particle size which we need or which is our desire to formulate the formulation. Okay. Milling. Okay, very important term is mill. What is mill and what is milling? Okay, milling is a process in which particle size of solid substance is reduction coarse or powdered state by employing mechanical strength. Apart from this, if we are taking example of size reduction, what happens, we just put that bulky mask in any machine, and the outcome was the fine or coarse or reduced size particle. So the machine in this whole procedure is known as the mill, and the whole procedure is known as the milling. Okay. In some cases, the process of size reduction is also known as grinding. Okay. In common terms, if we talk about the common terms, what we basically called it as grinding. What happens in any container or any vessel, there is a center shaft attached with the cuts or blades. What happens, that rotate on its axis on high rotation, and the amount or the compound we have stored in that reduces its size by cutting them. Okay, that procedure is known as grinding, and in common terms, the size reduction is also called as grinding. Okay, depending on the type of material used, solid or liquid, the methods employed for the reduction of particle size are broadly categorized into two classes. Okay, if we talk about the formulation, what happens, the formulation are of basically solid, liquid, and gases. But if we talk about the solid and liquid, there are two phases, either solid or the liquid. If we talk about the size reduction in solids, basically the method in our mind came out as grinding and cutting, the basic methods. What happens, if we talk about the grinding too, the vessel has the shaft and the blade in that, and it cut out that compound on high rotation. Okay. For the liquid, the process is called emulsification and atomization. Moving forward, for the advantage of the size reduction, it maintains content in uniformity and uniform flow of material. It enables the extraction and drying of drug in effective manner. Okay, if we talk about the what is the basic advantage of any size reduction particle, the very basic amount, it just maintains the uniformity flow of that material. And the second, if we want to extract something out from that particles, you see, if we are taking example as plant originated any drug, like if we are expecting a plant originating leaf has some active constituent, what we need to do, we have to dry that up, we have to grind that up. So if the grinding particles are very fine, the extraction procedure will be rapid, and the more and more active constituent will be get. Okay, it improves the absorption and dissolution rate and physical stability of the product. Okay, as the particles will be fine, the dissolution and absorption rate will always be high. It enhances the viscosity and surface area of the drug. It improves the drug viability. It aids in manufacturing aerosols, inhale, ophthalmic parenterals. Okay, this is the main point. Ki, if we need to develop any aerosols, inhalation, ophthalmic preparation or parental preparation, the particle size will be very fine. And it not stuck any track. The particle size should be very fine. Okay. Moving forward, for the disadvantage of the size reduction, it may degrade the drug quality or drug. It lead to the poor mixing. See, if we talk about the size reduction particularly, if we are taking example that I am having the API in very fine powder, but the additives are in coarse. So what happened? The mixing cannot be uniform, and the mixing leads to the poor mixing. So every component should be in the uniform size. It may lead to the product contamination. It may also lead some instrumental problem like noisy environment. Objective behind the size reduction: by reducing the size of particle, the surface area of the drug increased. Hence, in any case of any chemical substance, this increased surface area help in quick formulation of the solution. As we all know, if we are talking about the liquid formulation, the particle size are finer, the quicker formation of solution will be occurred. Means the particle size is finer and finer. It rapids or quick up the formulation process of formation of that solution. Okay, by reducing the particle size of certain drug, their therapeutic efficacy get enhanced. Okay, if we talk about the enhancing the therapeutic activity, it is very mandatory to just having the finest particle size. Okay, if the particle size of different solid ingredient is reduced to the same size, their mixing become much easier. See, I've already told you, if I'm having the finest API powder, but having another additives in coarse powder, that will not produce any uniform product. But if I'm having the finer API and the finer additives too, that may product the uniform formulation or uniform product. Okay. In order to increase the stability of emulsion, the size should be reduced. By reducing the particle size of ointment, paste, creams, their physical appearance can be enhanced. Okay, if we talk about the emulsion case, the reduced fine particles enhances its appearance too, but also its stability too. So if in case of emulsion, what happens if we touch and the sensation of that particle size comes in hand, that would look good now. That's why this emulsion, in case of emulsion, the particle size should always be fine. That may enhance the stability and the appearance, enhances the appearance too. Okay. It facilitated drying of the wet masses by milling. As the milling increases the surface area, and hence the rate of drying increases. Okay, or it also reduces the bulkiness of the drug. In case of if we are talking about the drying, the granulated particles dry slowly in comparative of fine particles. Okay, and it also reduces the bulkiness of that drug. Okay. Okay, moving forward, what are the factors affecting the size reduction? These are the basic 5 factors: toughness, hardness, stickiness, moisture. Toughness, those crude drugs are usually tough in nature, which have higher water content or are soft and fibrous. Problems are faced in size reduction of soft but tough substance as compared to hard and fragile substance. Okay, if we talk about the tough substance, it may be harder to reduce the size, but comparison of the components having the soft nature, the tough are the more chances to get the reduce their size to the finer particles. Okay, hardness, the size reduction of this of soft material is comparatively easier than the hard substances. Hence, the process of size reduction is also affected by the hardness of material. If we talk about hardness, the hardness of that particular component may also affect the speed of reducing that particular compound size reduction, while the soft material may not affect that process or any other thing. The stickiness, oh okay, if we talk about the stickiness, so if it suppose our components is sticky in nature, and if we run through that process of size reduction, what happens, that sticky substance will stick on the walls. Okay, moisture content, if any components having moisture in that, what will happen, the moisture content, if we suppose if that is going through the that machine, that will stick to the hammers or the blades or the walls there, or if in case it get a size reducted, what happened, it will be in the course. Okay, or if after size reduction it may also attach with each other, so the drugs which are moisture content active will also affect they will also affected by the size reduction process. See, next is the method of size reduction. Basically, these are the four basic methods that are involved during the size reduction method, that is cutting. The basically I have already told you, with the help of blades at any particular place, the circulatory blades rotates and the material inside that cuts. And compression in this method, what happens, any mechanically or forcefully thing is objected to the particle so that it may crushed into smaller particles. In impact, what happened, we keep up our that components as stationary fees stationary, and any moving object will hit it with high speed continuously, so that the particle size gets strike with it and the particle size will reduce. Okay, equipment for the size reduction. The basically these are the four common size reduction equipments or mills, you can say that, which we used in the pharmaceutical industry: hammer mill, ball mill, fluid energy mill, and disintegrator. Hammer mill. Okay, the very first mill, I'm going to give a brief introduction about this. Hammer mill is a type of crusher used for grinding and pulverizing various materials. It is a device used for crushing or milling agglomerate large size. See what happened in hammer mill. What happened? Principle of this is impaction. Already told you, there is a particle which be in stationary force and very high stationary motion, and very high force of something just strike that, so that the particle just is shedded out in a small particles or a fine particles. Okay, okay, if we talk about the basic hammer mill, what happens, there is a see here, there is a hooper through which we just feed up the particles, and it goes to this milling chambers. This is milling chambers, and these are this is the shaft which continuously rotates on its axis, and the hammers are attached with it. As the particle goes through this hoopers and goes through this shaft, what happens? The particles get strike with this hammers and the walls too. Double striking, due to double striking, what happens, the particle size get finer in size. Here is in last at the bottom of the mill, there is a screen having the mesh, particular size mesh, through which the reduced size particles pass through, and at the bottom there is a receiver or a container in which the whole powder is get stored. Okay, so this was the basic construction, already I have told you, and the working too. Moving forward, we are looking for the application for the hammer mill. In pharmaceutical industry, it is used in wet dry granulation and to disperse powder mixtures. It is used for grind pharmaceutical raw materials, herbal medicines, and sugars. It is used to make powder of bark, leaves and roots having medicinal properties. It is used for milling active pharmaceutical ingredient. Okay, if we talk, if I'm going to talk these about different ways. First, we talk about the herbal. If we talk about the herbal ways, what are the herbal basic components by which we extract the material is tree bark, leaf, root, flowers, everything related to plant. If we want to just reduce their size, what we need to do, we have to do dry that. Then we go then that components that um, part of the plant undergoes the size reduction. So this is basically used for the nature plant size, plant part size reduction also, making them powder. Next, if we talk about our allopathic or API or chemical things, so active pharmaceutical ingredient. For this, we also use if we got any chemical API in a very bulky manner and we need to reduce their size. So we that APIs also undergoes this process and excipients too. Okay. Okay, what are the merit? Its reductions ratio and capacity are high for primary, secondary, or tertiary grinding. It requires moderate energy. It is used for milling variety of material. It is easy to install, dismantle, and clean. It requires a small space for disinstallation. Okay, it's having very good kind of merits. Firstly, it having the capacity of three kinds of grinding: primary, secondary, tertiary. If we need a very minute the particle, the compounds, the thing we are going to grind, the thing we need to have the particle size are very delicate, we can just run that on primary. If we think that need a much hardened process, then we can go through the secondary or tertiary grinding. Okay, or second thing, it can be easily installed, it can be easily handled, it can be easily cleaned, it need very small space for the installation. So these are the basic advantage for this mill. Demerits: it cannot be used for fine grinding of hard or abrasive material. Okay, if we talk about the very toughest, very hardest compound, so it having a demerit that it cannot produce a very fine powder for that hardest or toughest part components, or it will also get choked. If we talk about the milling procedure, uh, if we talk about that shaft through which the feed was going inside the machine, if we are just putting unnecessary thing over there in unnecessary amount, it will also get choked for that, and it will also get heat generated on the high speed. So it may also damage the compounds that are heat sensitive due to it produces high heat at high speed. Okay. Moving forward, the next mill is ball mill. Ball mill is one of the type of grinders employing in grinding the drug substance into the superfine powders. These powders are used in the pyrotechnics, ceramics, and paint construction. Ball mill consists of the following part. Basically, all over, I'm going to give a brief introduction about this. Look, what happens now? The basic construction about this ball mill is having a cylindrical hollow here over here cylinder, and this is a metal stand. Okay, this is the basic construction for this. Okay, in ball mill, what happens? I'm just going to elaborate its working. What happens if we just rotate this cylinder on the axis, and what happens, we just put the steel balls in it, and the material which we need to reduce the size, we just put it in. What happens, it having the three aspects of speed. First, the lower aspect. In lower speed mein, what happens, the particle goes like this. So it just stick by the wall of that particular cylinder, and very less expectation of having very fine particles. And in case of high speed, it work as centrifugation. The whole particle gets stuck by the walls, and the centrifugation like procedure going to happen. And here also, the very less expectation of fine particles is getting. But at the correct speed, what happens, the particle size goes like this and fall down. The particle size goes like this and fall down. In this speed, what happens, the metal balls and the particle just go like this and just fall down. So after falling down, the particles are strike with each other. The particles are also strike with metal balls. The particles are also strike with that surface area of cylinder. So the chances of getting fine particles are more in this kind of mills other than the hammer mill. Okay. So already I have elaborated the working, low speed, high speed. Okay. Okay, later on after the particular time period, the material being grinded is withdrawn from the container and passed through suitable sieve in order to obtain the powder desired particle size. Okay, after the particular time which we need as we think now it's okay, now the particles would be fine. We just do withdrawn that whole components to a container and we just sieve it so that we can get our desired size particles. Okay. What are the application? It is the key equipment for regrinding. It is widely used for the cement, silicate, product, new type of building material, fireproof material, chemical fertilizer, black and non-ferrous material, glass, etc. It can grind ores for other material either by wet process or by dry process. Okay, if we talk about apart from the pharmaceutics, what happens now? If we talk about the particular application apart from pharmaceuticals, we all have seen that civil engineering department having the, if we talk about the sealing procedure, what they are having the cement mixing machine. This is the basic example related to that also. What happens in this kind of machine, we just put that grinders, everything ingredient and that mix that. Same thing is this. Okay. So application is over there also. This is a kind of example like that also. A key equipment for regrinding. If we want to continuous grinding of that particles, so it is a key equipment for regrinding. Merit. It can also be easily cleaned and operate. The grinding process can easily be seen. During the grinding process, there is a minimum loss of material. Both dry and wet grinding can be processed. It can produce a very fine powder. Okay, these are the basic merits, that it can be clean easily. It can be if we want to see how much the powder is fine, we can see it easily. The grinding process has the minimum loss of material, the very basic, because as we all know, the chemicals are very sensitive, very expensive. So this is the biggest, you can say, the advantage for this key. It has the minimum loss of the materials that we are going to that the going through this process in this. Okay, both and dry wet grinding process can be done and it produces very fine powder. Okay, demerits are this: it has a larger size, it take way many space, plus it has the very strong vibration. See, it is maybe it isn't slow in process, but the vibration and the sound produced are very high. Okay. Moving forward, I would like to give a brief introduction about what is size separation. A unit operation used to separate or categorize the particles on the basis of differences between the physical properties of the particle like density, shape, and size is termed as the size separation. Okay. One of the Once the size of the material is reduced, it is subjected to the size separation technique in order to obtain the powder of desired particle size range. Particle size distribution is defined as the number of particle in each size present in the given powder of specific weight. See, what we have done, the first stage of formulation, size reduction is done. What next? We have got that size reduced bulky powder. Up now we need to separate that coarse particles, that fine particles, or which we want desired particle size. We need to separate that out either by equipment, any of the, either by sieving, either by meshing, any of the method. We need to separate out for the our further formulation. Okay. So basically, size separation is a method or the procedure of separating the particle size in any bulk form of powders. Okay. Objective behind the size separation. The technique of size separation, particularly sieving, is employed for the determination of average particle size and particle size distribution, which is considered as the first step in the manufacturing of tablet and capsule. If we talk about the terms of tablet and capsule, what we need, every particle should be in uniform size. So this is the very first step after reduction. You can say that after reduction, this is the very first step. This is the very first step that involves in manufacturing of tablet and capsules that we need, that is done by the sieving method, that is done by the sieving method, that the desired particle size should be separated. Okay, there are certain drugs which are needed in extremely fine state with the particle size of this, so that, so 10 mu, so that they can be absorbed from the, see, if we talk about the why we need the finest particle size, this is the biggest question. If you are asking the why we need the finest particle size, see, finest particle size has the tendency to get absorbed rapidly in our circulatory system. It has a tendency to get absorbed rapidly. What happens if we take about any example of that coarse or fine, the fine particle will absorb obviously rapidly, and everyone wants to be, the action should be rapid, the action should be best. Okay, size separation is also essential for the evaluation of efficacy of different equipment used for the process of reduction. Moving forward, where are the applications of size reduction? Release and dissolution. First, clinically, the particle size of drug can affect its release from doses form administered orally, parenterally, rectally, topically, any route of administration. Okay, if we talk about the application, it is clinically also proved that the finer the drug size, the finer the drug particle, the finer the action, the highest the release of drug withheld. Okay, if we talk about the only parenteral and tablet, the parenteral shows action fast. Why? Because parenteral has the finest particle and it absorb quickly. And what about the tablet? It dissolute, then उसके बाद process होने के बाद then वो absorb हो रहा है. Okay, absorption and drug action. See, already I have told you drug absorption and pharmacological responses are affected by the size particle. Higher dissolution rate, faster absorption, hence quicker the greater the drug action. Okay, if we talk about the, as already I have told you, the finest particle has the dissolution highest rate, and if the dissolution rate is higher, the faster absorption rate will be, and the quicker and the greater the drug action will be. Okay, physical stability, the finest particle, if we talk about the case of emulsion, suspension, any type of formulation, if there is having a finest particle, the stability will be always high. Okay, mechanism of action. First, agitation. This mode of motion involves vigorous shaking of sieves in the following way. If we talk about the basic method for the size reduction, what we do? Sieving. Sieving method is like shaking, vibrating any sieve so that the particle size get passed through it, and we can get the desired particle size. So these are the basically three motions that is involved during behind this mechanism. First is oscillatory motion. In this type of motion, the movement of sieves take place with the help of rotating shaft. In this, the sieve placed on the frame are moved into and fro motion corresponding to the plane of surface. What happens? There is a between a you can see a stand, and oscillatory motion is like rotating. And what happens? The particles kept in motion. Due to oscillatory motion, what are the particles are always in motion, and hence the particles are motion, there is a bigger chances to get the more and more particles to be passed through that sieve. Okay, vibrating motion, same. If we talk about the oscillation motion, what happens? There is a particle get in motion. Same in vibrating motion. If we In this type of motion, the material is placed on the sieve, which is then subjected to high speed vibration. What happens? The sieve is attached to the vibrating operators or anything that vibrate at higher motion, so that the particles in that just kept in motion, so that the highest number of particles should be sheaved out from that sieve. Okay. Same as gratatory motion. What happens? It like a flying wheel used to rotate in an axis, or what happens? The sieve is placed. over there, already sieved is placed, and the components we have already size reducted kept over there, and that is goes in the continuation motion where the highest number of fine particles, fine powders, or whatever we want in our desired shape, our desired size, that we get. Okay. Now, the classification of powders according to IP. Okay, if we are talking about coarse particles, fine particles, moderate, so there are the some things na, that differentiate what are coarse. How can differentiate? Okay, so these are the basic seven kinds of powders or particle size. First is coarse, in which the if we are reducted the size of powder. Now, if we are going to separate the powder, what happens, we just pass it through the sieve. But if we pass through that in sieve number 10, okay, and it is passed, and further we are going to pass it through sieve number 44, and only 40% of that weight pass through, the rest between them, sieve number 10 after sieving by sieve number 10, and uh, residue not the powder that not passes the sieve 44 number sieve, the powders between these sieves are always the coarse powder. Okay, if we talk about the moderate coarse powder, what happened, the sieve number 22 is the basic sieve through which the powders are passed, but the passed powders are, if we sieved again with 60 sieve number, not more than 40% of the powder should be sieved out, and the powders between these two sieve numbers are always moderately coarse powder. Okay, moderately fine powder, same as like coarse. Sieve number 44 is the basic sieve for this, and if we sieve out the particles through it, the powders we get after sieving, that powders 40%, no, not more than 40% should be passed through sieve number 85. Then the powder will be moderately fine powder. Same as for fine, the basic powder sieve is 85 and the secondary is 120. Very fine powder, the basic sieve is 120 and secondary is 350. Microfine case, if we talk about the microfine case, the powder bulk we have having, if we sieve through that, sieve, there should not be passage of particles not more than, not less than 90%. Okay, then the particles will be microfine particles. Okay, we are talking so long. Sieve. Now the sieve is here. Normally, a sieve is used for separating the unwanted or useless material from that of the desired one with the help of different tools such as net, mesh, or other distillation and filtration technique. Okay, what we all know already, we know that the sieve is a you can say that equipment or anything that are used to separate out unwanted particles to separate out, and the sieved out thing is our desired. So basically sieve having the same concept na, when we sieve out the 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 sieved out things are desired, and the residue upside of the mash is unwanted particles. For the separation of liquid from solid, particular type of sieve is known as strainer. If in case of the liquid having the solid particles, what we use a strainer as a sieve. Okay, the specification given below will be matched by the sieve used for pharmaceutical testing. Okay, if we are saying that it is a pharmaceutical sieve used for the pharmaceutical industry, the following are the basic parameters specification that should be matched so that it can be used or for the pharmaceutical field. First is sieve number. This is the number of meshes present per linear length of 25 point per mm. What is the sieve number? This is the number of meshes. Message मतलब जो that passage 25.4 mm के range में जितने भी passage will be present, that is the sieve number. That will denote the sieve number. Nominal aperture size. This is the distance between two adjacent wires representing the sides of the square. Okay. What happens now if we talk about the nominal aperture size? What if we see the mesh, it having the two this the kind of wires and two this kind of wire. So distance between these and this, always represent the nominal aperture size. Nominal wire diameter, this should be specified diameter for every mesh. Approximate percentage sieving area. Okay, this is the main thing. Approximate sieving area, how can you define? The outer area, the holding area should be 30 to 40% containing weight, so that the if we put any bulk in that, so the sheave can be hold that. Okay. Aperture tolerance area, some variation which the aperture size undergoes cannot be avoided. Such variation are termed as aperture tolerance average expressed as a percent. They are the some minute changes or the tolerance level which can be ignored, that can be denoted as aperture tolerance average size. Okay. Moving forward, the next mill for the separator is cyclone separator. The method used to remove particulate matter from the air, gas, water, storm with the help of sea. I'm going to give a brief introduction about this. What happens in cyclone separator, the high speed of fluid goes through this, and as the highest speed of fluid goes through this, the cyclone in this already the figure is here. The conical section is bottom, at the upper section there is a cylindrical area. So what happened when we flow highest pressurized fluid over here, the fluid get in cyclone motion. As the cyclone motion happens, the particles settle down and the water kept at upper surface. Then we separate out our water and the particles settle down. We separate it separately. Basically, this was happened and this was used for the formulation of suspension to separate the particles from suspension. Okay. So this is the basic concept of separating any particle size from suspension, that at high speed the liquid is flows and the highest particle size which was undesired for the solution that settles down and the solution was separated out, unwanted particles we just separated out. Okay. This was the construction and working already. Already I have told you. Application. It is used for the suspension of separation of suspension. Already I have told you, of solid and liquid, with preference for the suspension. Or if in case of gases, it was already denoted over here. It is also used for separating the heavy or coarse friction from the fine dust. Okay, so it is having the another application that it will also separate the uh, air does too. Having the merits, it is very low capital cost, operating temperature are very high, and liquid mist, it can be used for the liquid mist and dry materials too. Maintenance costs are less, requirements are less, or small space installation here. Okay. Okay, this is for today, and thank you for